Good day, grade 11 STEM students. Welcome to the HP Classroom. This video is a continuation of the review on sequences and series. For geometric sequence, it is a sequence in which each term is obtained by multiplying a constant called common ratio to the preceding term. And this is the formula for finding the nth term of a geometric sequence. A sub n is equal to a sub 1 times the common ratio raised to n minus 1. So for this example, we need to find the 10th term of the geometric sequence 3, 6, and 12. In this sequence, 3 is our first term, or a sub 1. And we're looking for the nth term of this sequence. But first, we need to list down all the given. A sub 1 is 3, our n is 10, and our common ratio is the quotient of the second term and the first term, 6 divided by 3, which is equal to 2. And let's substitute these values to the given formula. Let's rewrite it again. We have a sub n is equal to a sub 1 times r raised to n minus 1. We're looking for a sub 10, or the 10th term. So we have 3 times, the common ratio is 2 raised to 10 minus 1. Let's evaluate. We have 3 raised to 2 raised to 9, so we have 3 times 512, because 2 raised to 9 is 512. After multiplying 512 by 3, our 10th term is equal to 1,536. So this is our 10th term, 1,536 for the geometric sequence 3, 6, and 12. For geometric series, we can use many ways in finding the sum of the geometric sequence. For example, what is the sum of the first 5 terms of 3, 6, and 12? We will use this S sub n formula if our common ratio is not equal to 1. A sub 1 times 1 minus r raised to n all over 1 minus r. So let's observe that 3 is our first term, and we're looking for the sum of the first 5 terms. N is equal to 5. We will just list down all the given. So our a sub 1 is equal to 3. Our n is 5. And our common ratio is 6 divided by 3, which is equal to 2. Then, we will substitute this given to our formula. S sub n S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. So we have S sub 5. Let's substitute. Our a sub 1 is 3. 1 minus the common ratio is 2 raised to 5 all over 1 minus 2. So let's evaluate. So we have 3 times 1 minus 2 raised to 5 is 32 divided by 1 minus 2 is negative 1. To continue, we have 3 times negative 31 over negative 1. We can cancel out negative 1 because it will be equal to 1. And then our S sub 5 will be the product of 3 and 31, which is equal to 93. So the sum of the first 5 terms of 3, 6, and 12 is 93. For the next example, what is the sum of the first 10 terms of 4 plus 4 plus 4 and so on? Again, let us take a look at the first term, which is 4. We look for the n, which is 10, and we're looking for the sum of the first 10 terms. Let us list down all the given. A sub 1 is equal to 4. N is equal to 10. And the common ratio is second term divided by first term, or 4 over 4, which is equal to 1. For this example, I will list down all the terms needed to be summed up. So here, it is already written. So we have 10 terms of 4. So obviously, our sum is 40. So how did we come up with that sum? We will derive the formula S sub n for this given condition. So as we can notice, our n terms is equal to 10, or the first term is repeated 10 times. So our a sub 1 is 4. So we have the product of n and a sub 1. So our S sub n is n times the a sub 1, or the first term, given the condition that r is equal to 1. So S sub n is equal to n times 1 when r, or common ratio, is equal to 1. So what is the sum of the first 10 terms of 4 minus 4 plus 4 minus 4, and so on? So in this example, our a sub 1 is 4 and our n is 10. We need to look for the sum of its first 10 terms. Again, we list down all the given. A sub 1 is equal to 4. N is equal to 10. And the common ratio is negative 4. Second term is negative 4 divided by 4, which is equal to negative 1. Like the second term, I will just list down the first 10 terms of this given geometric sequence. So we have 4 minus 4 until we reach the 10th term. Let's solve for our S sub 10. So 4 minus 4 is 0. 4 minus 4 is 0, 0, 0, and 0. So we come up with the answer of S sub 10 is equal to 0. On what condition? So that is S sub 10 is equal to 0. So let's derive a formula that S sub n is equal to 0 when the common ratio is equal to negative 1 and when n is even. For example number 4, what is the sum of the first 9 terms of 4 minus 4 plus 4 minus 4? So again, let us examine the first term. Our first term is 4, our n term is 9, and we need to look for the sum. Let's list down all the given. A sub 1 is equal to 4. Our n is equal to 9. Oh, sorry. That is 9. And our common ratio is equal to the second term divided by the first term, negative 4 divided by 4, which is equal to negative 1. Just like the third example, I will just list down the first 9 terms of the series. Okay, so that is S sub 9. So our S sub 9 is equal to 4 minus 4 is 0, 0, 0, 0, and we are left with 4. which is, as we can observe, is equal to a sub 1. So our answer for S sub 9 is 4. So we can derive the formula that S sub n is equal to a sub 1 when the common ratio is equal to -1 and our n is an odd number. For the last example, for geometric series, what is the sum to infinity of 3 minus 1 plus 1/3 minus 1 over 9 plus and to infinity? So this is an error. So that is not there. So that is 3 minus 1. So we need to look for the sum of to infinity. So we will use that formula. S sub n is equal to a sub 1 over 1 minus r. So our a sub 1 is 3. Our n is infinity to infinity. And we need to look for its sum. So let's list down again all the given. A sub 1 is 3. N is infinity to infinity. Our common ratio is -1 divided by 3, which is equal to -1/3, which is less than 1. So let's substitute the values. S sub n is equal to a sub 1 over 1 minus r. Sum to infinity is equal to 3 divided by 1 minus -1/3. Then let's evaluate. We have 3 divided by 1. Negative times negative is positive 1/3 equals 3 over, so let's get the LCD. We have 3 plus 1, then copy the denominator. So we have 3 divided by 4 over, that is 4 over 4/3. So we'll just change that. So that is 3. So for cross multiplication, we have 3 times 3 is equal to 9. And 1 times 4 is equal to 4. So our sum to infinity is equal to 9/4. I will just box it here. So that's the final answer if the common ratio is less than -1. So for harmonic sequence, it is a sequence formed from the reciprocal of an arithmetic sequence. So in here we have 1 over 9, 1 over 12, 1 over 15, 1 over 32, 1 over 39, 1 over 48, 153, 160, 1, and there. So since it's arithmetic sequence, we're going to look for the common difference. So in here we have 3 common differences. So the first one has a common difference of 3. The second harmonic sequence has a common difference of 7, and the last sequence has a common difference of -9. However, the difference is they are in the form of reciprocal. For the Fibonacci sequence, it is a sequence that starts with 0 or 1 followed by 1, and the next term is based on the sum of the preceding 2 terms. To find the next term, we'll start with 0 and 1, then add the first 2. So 2 plus 3 is 5, 5 plus 8 is 13, 13 plus 21 is 34, and 21 plus 34, and so on. And to get the next term, you need to get the sum of the preceding 2 terms.